All right. Now, what I'm going to do today is give you a few techniques of solving simple trigonometric equations. I use the word simple because it's sort of fairly straightforward. There's not a lot of complication. All right? And on the board, I say graphically, algebraically, and class pad. And seriously, I don't think any of us who writes a paper will give you solving trigonometric equation using class pad. It's just way, way, way not feasible. All right? It's too straightforward if you use class pad. I want all of you to think and solve problems. So I would say that most of the time will be either graphically or algebraically. You should recall the graphing of trigonometric functions. Should be able to use graph or trigonometric functions to solve a simple equation by looking for intersection points. Now, exact values is very important because most of the time, I would say definitely for the next test, you will do this in the calc free section. Pardon? All right, you'll be doing it in the calc free section. I've written the test, so I know that. You need to solve trigonometric equations over a given domain using the reference angle. And recognize the change in period represents a change in domain when solving a trigonometric equation. Then, of course, using class pad. We'll see. I'll show you class pad very quickly, but don't expect all of you to do it. Now, a trigonometric equation is one that involves solving for values of the angles that satisfy the given value of sine, cos, or tan. For example, what is sine x? What is x? X, sorry. Sine x is half. What is x? Hey, what? Give me a value of sine x. X, sorry.
30 degrees.
X equals to 30. Do you think that's correct? Honestly, there's only one of the solutions. Think about it.
150.
X rotation. So also think about your quadrants.
150.
150. All right. And so on and so forth. All right. Could it be measured that way? Negative.
No.
Could it be minus 210 degrees? 180 plus 30 minus 210 degrees is over here. Yeah? Could it be minus 330 degrees? Now, the thing is, with all this, you're not given a domain. So you don't know what is the right answer. So in fact, if you're given something, the correct answer should be x equals to 30 degrees plus or minus n times 360 degrees, where n is an integer, or 150 degrees plus or minus n times 360 degrees. All right? Because you're doing the rotation. You keep on rotating. So you know that when sine x equals to half, it could be anything from 30 degrees plus or minus 360 degrees. All right? So cos theta equals the square root of 3 over 2. Theta equals to, what is it? 30 degrees as well. Right? Again, theta would be something like this. And of course, tan alpha 45 degrees plus or minus 360 degrees. Now, so if you use class pad using solve function, class pad will give you x equals to 30. However, think about it, sine is actually the y coordinate in the unit circle. Correct? So therefore, what would happen is, here, you may have half here, and the other one is half here. So therefore, like I said, you could have 150 degrees or 30 degrees or keep going. All right? So now, what if I have, use a different color, cos equals to square root of 3 over 2. Cos would be x. So again, it's here. Oops, wrong color. I want to use a different color. All right, let's use this. highlight that, you'd be square root of 3 over 2. And the next one would be there, 330 degrees. So you got to think about where actually is the x coordinates or the y coordinates. So here, you know sine x equals a half. Alright? So half is there. What about tan? Tan you got to think about here. That will be positive, that will be positive, correct? Yeah? So you can see that it's located everywhere in that circle. And you may have to go around the circle in the clockwise direction or anti-clockwise direction. Right? Now, can you use a graphical approach to solve the following? This time, what I've done is restrict the domain to minus 2 pi to 2 pi. So if we restrict the domain to minus 2 pi to 2 pi, it makes life a little bit easier. You know exactly what we're looking for. Correct? So now, what we need to do is, I know 2 sine x equals to 1. Alright? Therefore, we know sine x equals to half. Alright? Before that, let's write all this down. Sine x will be equals to minus 1. Sine x will be equals to 0. So what we need to do is actually plot the graph of sine x for minus 2 pi to 2 pi. So when x is 0, what is sine x? 0? Yeah? Yeah? Okay, good. Try to wake up. Alright? So you know that will be something like this. 2 pi is here. Alright. Now let me plot the graph. You've got the sheet in front of you. You can follow me with this. Alright? Now, with this, what we need to do is when we have sine x equals to half, let's draw a straight line when sine x equals to half. There. This is half. Oops. So this is 1. This is minus 1. Therefore, this is half. Alright? You got this point here, this point here, this point here, and this point here. And you should be able to work out what are those points. Correct? So here, what is that? If there's pi, what would that be? Pi over? Yep. So x would be, now pi over 4 and this one would be 3 pi over 4, correct? What about those two? What is this? Come on.
Negative 7 pi.
So negative 7 pi over 4. Thank you. What about the other one? Come on, use your brain. Wake up.
Negative 5 pi.
And that one is pi over 4 and 3 pi over 4. Thank you. Now, sine x equals to minus 1. Let's draw it. Sine x equals to minus 1. Use a different color.
That's the pi.
All right. Only two solutions. So that would be, x would be minus pi over 2. What else? What else? Pi over 2 minus pi over 2, and what is this?
3 pi over 2.
Thank you. Come on, wake up. What about when sine x equals to 0? Sine x equals to 0, you've got all that value there. So, you've got this value, this value, this value, this value, and this value. Therefore, x equals to minus 2 pi, minus pi, 0, pi, and 2 pi. All right? When you've got graphical approach, you need to be able to draw your sine curve or cos curve or tan curve, and then draw a straight line and go through and make sure that you know you've got all the points there. 1, 2, 3, 4, 4 solutions for that, 2 solutions for this one, and 1, 2, 3, 4, 5, 5 solutions. You can see that there are plenty of solutions because it goes on as a waveform. Alright? It goes on and on. So, the concept is we are given a trigonometric equation and we have got a domain for theta. So given that trigonometric equation are defined by unit circles, there are infinite many angles that can satisfy a trigonometric equation. This is because we can keep on completing revolutions of the unit circle. Remember, you can rotate round and round and round and round. Hence, the domain of a trigonometric equation places a restriction on the possible value of theta. You always need that. The domain is so important. It could be 0 to 360 degrees. You could have been given minus pi, theta, and pi. Oops. And so on and so forth. There are many ways of doing it. There are many restrictions. Alright? So now, what would you say a standard domain? When we solve for sine or cos equation, standard domain. 0 to 360 or 2 pi. 360 degrees or 2 pi. Alright? 10 is, what would that be? Pi. Because that is one period. Think about the natural domain. Alright? Now, let's go on and move on to the next one. Oops, I've written that down. Can you solve then the following trigonometric equation? Cos theta equals to half for theta between 0 and 360 degrees. Now, what I would do, the way I would do it is I actually start drawing a Cartesian plane, y and x. We know what I want is the reference angle. When cos theta is half, what is the reference angle? 60 degrees. Now, you know C, A, S, T. Right? So therefore, you know, if it is positive, it could be in quadrant 1 and the other one could be in quadrant 4. And that will be 60 degrees as well. Alright? However, what we wanted is from 0 to 360 degrees. Therefore, theta is 60 degrees. And measuring from here all the way up to that, which is 360, take away 60 degrees is 300 degrees. Alright? That's how you do it. Alright, tan theta equals to square root of 3. For 0 and between theta between 0 and 540 degrees. What would theta be? Reference angle? 60 degrees. Alright? You know it would be quadrant 1 and quadrant 3. Alright? So start off with theta would be 60 degrees, followed by 180 plus 60, 260 degrees. Now, keep on going. 360. 360 plus 60 is 430 degrees. Then we go on to here. Would that angle be greater than 540? It is. So the only solutions are 60 degrees, 240 degrees, and 430 degrees. Alright? Next one. When we have 2 sine x equals to minus square root of 3. Alright? We know that sine x, oops, where am I? So we know that sine x is therefore minus square root of 3 over 2. Alright? Now, what's the reference angle for this? Square root of 3 over 2? Sorry?
60.
Sine x is square root of 3 over 2 is 60 degrees again. Alright. Now, what I want you to think about is, I'm going to show you step by step how to do it next. So, suggested method is always, you manipulate until you have got sine x equals to something, cos x equals to something, or tan x equals to something. I've shown you the first step. And then reference angle, pi over 3, because it is given in radians. Think about the sine and quadrant, negative, third and fourth quadrant. I always like to sketch it. All right? I always like to sketch it because I know that sine is negative, therefore I know it's third and fourth quadrant. I always like to sketch it. That's my technique of doing it. And then I put a star so that I know is which quadrant I'm looking for. And then apply the reference angle with respect to the horizontal. So therefore you know, because it's between minus 2 pi and 2 pi, it's minus 2 pi over 3, minus pi over 3, 4 pi over 3, and 5 pi over 3. So you know this is the reference angle, pi over 3. I put a dotted line in to indicate to myself that this is not the angle that I'm looking for. Solid line, so I know I have got to work out the angles which is associated with the reference angle, and it's in third and fourth quadrant. That's my technique of doing it. But again, it's up to you. If you're comfortable enough not to have the dotted line and not to have the Cartesian plane, that's fine. This is just a suggested way of doing it. If you can just straight away see it as a negative and see it in the third and fourth quadrant, go ahead and do it. All right? Now, of course, you can solve it using ClassPad. You can try getting ClassPad out and work on something like this. If you want, grab your ClassPad and do it. If not, we'll do it a little bit later. It is up to you. ClassPad you can solve numerically with lower and upper bound. It could be pi, minus pi, and plus pi. It is up to you, but if you use minus pi and plus pi, make sure that you change the degrees to radian. So it's up to you to play around with it, or you can try it now. A couple of minutes. Like I say, in the exam, I would say that most of the questions, you will be doing it without your ClassPad. There are many ways of setting a limit. The other way of doing a limit is solve, and then I put a straight line, indicate where x would be. The range of x, or actually the domain of x. All right? So once you've given it the domain, it will actually tell you the two angles that you will get. Yeah. All right, let's move on. All right, changing domain. When solving a trigonometric equation that has a change in period, we must take into account the effect on the given domain. So consider the graph of y equals sine of 2x, which is drawn there. Can you solve graphically sine of 2x equals 1? For minus pi to 2 pi. Of course you can. All you need is, with a graph, draw a straight line. Correct? I'm looking for my ruler. Draw a straight line, which means what you can do when x equals to 1, 2x equals to 1. Draw that. With that line, you know that your solution is there. All right? So you know that 2x is minus 3 pi over 2, pi over 2, and 5 pi over 2. And therefore, x would be equals to minus 3 pi over 4, pi over 4, and 5 pi over 4. All right? Pretty straightforward if you use a graphical method. However, if you don't have a graphical method, if you're asked to solve this, what do? Again, we will manipulate until we have sine bx equals to something. This time, you can either do this first or do this first. That first. It really doesn't matter. If you think about the reference angle, 2x will be pi over 2 minus 3 pi over 2 and 5 pi over 2. All right. Now, the change in domain is important. Here, what you're looking at is when we have to solve for x between minus pi and 2 pi, right? However, we've got 2x there. So we know that we have to change the domain when we solve for 2x. We multiply both sides by 2. Therefore, it will be between minus 2 pi and 4 pi. Alright? That's quite important for you to realize. You must be able to change the domain. Realizing the fact that there is a domain modified to suit the period change. And then think about the sine and quadrant again. Sine and quadrant, sine and 2x. Sine 2x is 1. So, CAST. I will say that here and here. Alright? And therefore, you know that are solved with the old domain. So x is therefore pi over 4 minus 3 pi over 4 and 5 pi over 4. Alright? Now all this has to be within that domain. Alright? Cannot be greater than 2 pi. All this has to be within that domain. Right. Now let's try to do a couple of questions. Start off with this. It's up to you whether you want to change the domain first. Generally, when I look at a question like this, I will start manipulating until I get cos x over 2 equals to square root of 2 over 2. Alright? Then, on this side, I will write the new domain, which is minus pi, x over 2, and pi. Divided both sides by pi, so that we got the new domain. We change the domain. Now, we know that cos x is square root of 2 over 2. Let's draw the reference angle. CAST. You know that is quadrant 4 and first quadrant and fourth quadrant. And we know that it will be pi over 4. Alright? So now we are going to look at from minus pi, which is here, to here, to pi. Correct? X over 2 is minus pi to pi, which is this circle here, from the third quadrant to second quadrant. And you only know that, we know that these are the two angles that we need. So therefore, x over 2 is minus pi over 4 and pi over 4. X therefore equals to minus pi over 2 and pi over 2. Alright? Then you bring it back to this domain. And make sure that those two are within that 2 pi, minus 2 pi and 2 pi. Alright? So if you can see that minus 2 pi is here. Alright? So you know there's angle here, there's angle, and back to 2 pi. Which is here. Now the next one, tan squared equals to 2x. This time, you know tan 2x will therefore be equals to plus or minus 1. Alright? And let's change this, 0, 2x, and 4 pi. Change the domain. Make sure that you've got a square. If you've got a square, the square root is plus or minus. So, you now know what we are looking at is the solution will be in all 4 quadrants. Correct? Because you've got plus or minus C, A, S, D. So if tan 2x is plus 1, you'll be looking at these 2 quadrants. Tan 2x is minus 1, you'll be looking at these 2 quadrants. So you know that it covers all 4 quadrants, and you know the reference angle is pi over, what is it? 4, thank you. So you know that's pi over 4. Pi over 4. Pi over 4. You're taking into account all the quadrant plus or minus. And now, we're going to solve between 0 and 4 pi. 0, to 2 pi. That's one rotation. And second rotation. 2 pi and 4 pi. So therefore, 2x equals to pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, then plus 2 pi, 9 pi over 4, 11 pi over 4, 13 pi over 4, and 15 pi over 4. So therefore, solving for pi will then be pi over 8, oh sorry, not x, 2x, not pi. That should be x. 2x. X will then be pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 4, 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8. Alright? So important thing in this case, when you've got change in period, you must learn how to change the domain. This is a new domain. Alright? So multiply everything by what is in there. If it is 2x, multiply everything by 2x. If it is half x, multiply everything by half x.
So you wrote 7.
Alright? Sorry? Oh, 8. Thank you. That's alright. Alright? Now, so make sure that you know when you're solving what quadrant you're in. Alright? Just to recap, so make sure that you manipulate until you've got sine bx or cos bx or tan bx. And then look at the reference angle, look at the new domain, and then think about the sine and quadrant and solve within the old domain. Always solve within the old domain. Alright? This is the lesson, and for today, hopefully, I have actually gone through all this and make sure that you know how to solve trigonometric equation.